All right, so we're going to talk about here looping. Specifically, we're going to look at for loops, but there's another kind of loop called the while loop. And so we're going to start by just doing some basic stuff. And so what a loop does, and we'll specifically do a for loop, is it basically will do this, repeat the same code over and over and over again a certain number of times. Okay? And so the way it works is we type for, and the simplest one we could do is we could say for x in range, say 15. And then we could print x, something like that. Okay? Now what this will do is it's going to start counting at 0 and then up to the number 14. And then once x is equal to 15, so basically every time through the loop, this value of x gets a little bit bigger. So when we print it out, we're going to see it print out a 0, and then a 1, and then a 2. And what's happening is each time through this loop, that value counts up. Okay? I'm just going to do that until we get to 15. Then it's going to exit that loop and go to line 4. But let's go ahead and try running this. So we're going to say python looping.py. We run it, and you can see here it printed out 0, 1, 2, 3, 4, 5, all the way to 14. Then it said the loop is over here because we ended that loop. Okay? If we want to add some time so we could watch it happen, we can import a package called time. Okay? And so this time package allows us to basically keep track of time, as well as, so like if we want to time things, as well as to have like delays. And so we're going to say time.sleep, and then we'll say 0.1. So that means it's going to take every time through the loop, it's going to go 0.1 seconds. Now I'm going to show you something real quick. This line here is tabbed over, as is this one. Those lines being tabbed over mean that they're part of that loop. If we remove the tab on this one, it's no longer part of the loop. Okay, and we'll see what both those look like. Make it a little bit longer here. And so we're going to run this. And you can see it kind of slowly runs those numbers out, and then it says the loop is not over. And you can see it's taking time to push those out because we have this break in between each loop. Okay? If we remove the tab here, you can see it's going to happen a lot faster because it doesn't pause until after it's printed through that whole range. So having this be a part of the loop, you can see it takes longer because it's doing that every time. Okay? And so this is a for loop. We can also, instead of going from 0 to 15, maybe want to go from like 5 to 15. And so this will start at 5 and end at 14. And so we can set some bounds if we didn't want to start from 0 there. You can see that it did that. We can also set like an increment. So let's say we want to count by 2s. Then we can let's go from 0. Let's go like that. So we can count by 2s now. Oops, I should just run it from the thing. Right, you can see it counted by 2s there, 5, 7, 9, 11, 13. Okay, and so there's lots of stuff you could do with the for loop like this and with this range function. But you can also loop through things without the range function. So we can say, if we make a list, so we'll call it my list, and we put it in brackets, and we'll say 1, 5, 6, 8, 9, 45, 17, 23. So this is a list of numbers, and here we can just say for x in my list, it's going to now just print out the values from that list one at a time, instead of like counting up in a range. And so basically this works its way through. So the range function gives a list essentially values, and it iterates through those. And so we can use range to get our list, or we can make our own list. And so generally, if you're just counting up, using this range function is the way to go. And then maybe if you want to get an input, you could say user input, we'll convert it to an integer, get an input, and we'll say, oops, please enter a number. Okay, nope, let me close this. All right, and then we'll run it. Oh, and then we're going to say here, instead of going to 15, we'll go up to user input. Okay, and so if I run this and I type in 5, it's going to count up to 4, like that. If I run it again and I enter 15, now it's going to count up to 15. Okay, if I enter a 30, it's going to count up to 30. Okay, so you can see how this can be used in a way that's pretty flexible by adjusting that input. And then maybe you want to do something where you count like all the even numbers. Okay, and so let's make a counter. We'll start it at 0. And in here, we'll do a check, and we'll see if counter let's see, percent equal 2, or percent 2 equals 0. We don't need these parentheses. We will increment the counter. So we increment it as going like this: counter plus equals 1. Okay, and so we'll try this, and so we'll say print there are counter even numbers in from 1 to user input. Okay, I'm gonna make this, put the F in front to make it an F string, like that. Okay, and so we're gonna run this, and we'll see that there's a problem here. Okay, and so let's run this, and we're gonna say 4. So we should expect 2. It's gave us 1. Okay, and we don't need to print this right now, or we don't need that either. That's sleeping there because that'd make it take longer. So really, we would expect there to be 2 of them, right? A 2 and 4. So what we're going to do is we're going to say 1 comma user input plus 1, so it counts the last value. Okay, so let's try it again. Enter number 6. We should expect 3. Nope, something wrong here. Okay, the problem here is this. We should be comparing x here. That's what it was. Okay, so let's get rid of this. And now we're going to have a separate problem. The one I was expecting originally. Okay, so we're going to enter number 3. And it says we have 2 even numbers from 1 to 3. Okay, if I enter 4, it says 2. But if I enter 3, it also says 3. And the reason why is because it's counting 0. Okay, and so let's add a 1 there so we don't count 0. And so now the 3 works. There's 1 even number from 1 to 3. If we do 5, there should be 2. Right, we get 2 even numbers. But if I put in a 4, I'm going to get still just 1. Okay, and really I want there to be 2 because it should count 2 and 4. And so I have to add 1 to the user input so it increments that as well. Okay, and now if I run this, enter number 4, there's 2 even numbers from 1 to 4. 25, there's 12 even numbers from 1 to 25. Now, looking at this, this is actually a really bad way to count the number of even numbers in a range. So it's much better to use division, right? We could just take our input and divide it by 2. The reason why this is an inefficient way is because we have to count through and perform this check, right? This takes time. And this takes time. So these 2 things take time, and this takes time. These 3 lines take time. If we're doing that, let's say we want to count the number of even numbers from 1 to 1,000,000. You know, it might take kind of a lot of time. It looked like it was pretty quick there, right? But if we're doing more things with it, or let's add another 0, see if we can make this take time. So yeah, that was 10 billion, or that was 1 million. No, that's 10 million. Let's try a billion. So we're gonna go 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you can see that it's taking a long time. Okay, and the reason it's taking a long time is because it's basically iterating this loop a billion times. Okay, and even though one time through the loop is really quick, if we go through this loop a whole bunch of times, it starts to get really, really, really long. Okay, and so then we would want a more efficient approach for doing this. For example, you can really just do user input, the integer division, and then 2, and that's going to tell you how many times it goes evenly into that number. And that's how you would calculate the number of evens, or that would be a better way to do it instead of actually going through and counting. But you can see here, this thing is still going, it's still computing. It's probably going to take like a minute or two to go up to a billion maybe. But anyway, so this is a loop. There's another kind of loop that we can do, and I'll just show that real quick. And that other kind of loop is a while loop. And we can say while counter is less than 5. And what this one will do is it will continue to execute the loop until counter is no longer less than 5. And so if we say counter equals 0, and we can do counter plus plus, or plus equals 1, sorry, that was a C thing. I'm going to go ahead and get rid of this and this. Okay. And we'll print the counter here. Print counter. Oh, there you go. Our calculation finished. So we're going to run this, and it's basically what's going to happen is counter is going to be equal to 0. While counter is less than 5, it's going to print out the counter, and then it's going to increment it by 1. Okay? And you can see it did that. Now let's add some time to this. We'll say time.sleep. And we'll sleep a second. And now let's think about what might happen if I don't change the value of the counter, if I leave it at 0. And I run this again, and you can see it's just printing out the number 0. And because counter never changes, it's always going to be 0, that's always going to be less than 5, and this loop will continue forever. This is called an infinite loop. Okay, and sometimes you want those things, sometimes you don't. If we want to exit this program, the way that we're going to do it is we're going to use Control-C, which is called the keyboard interrupt. So I'm going to do Control-C right now, and it exits the program. Okay. And so, but you can see here this loop may go on forever, and so another way to do, just if you want an infinite loop, you can do something like this while true, and then it will run, like we said, forever. You know, maybe we want it to count, so let's add the counter here. And that's kind of like keeping track of time for us, right? So we run our counter. We can see it's counting up. It's going to keep counting forever because this is always going to be true. And so at some point, if this became false, then we could end the loop, but otherwise it won't. You can even see that the that VS Code here picked up on this, and it sees this loop is never going to exit, and so it shaded this part out because we're never going to see this line of code, because this loop will always go until I somehow interrupt it, like for example with the keyboard interrupt. Okay, and so this was just an overview on loops. This should hopefully get you started on doing some exercise with looping.